Great to have you with us again. Today's chapter explores the essentials of iOS networking, all through the lens of Swift 5.5 and SwiftUI. Today we're diving into building a robust networking layer for our app. If you haven't set up Macoun yet, you'll want to revisit that section as we will be using it to mock our API throughout this course. Today's mission is to create a reusable communication layer for our app. We'll leverage Swift's async await feature, which is like having a kitchen helper that allows you to multitask effortlessly. Before we dive in, let's outline what you can expect to learn today. We will cover endpoints, HTTP methods, request errors, client, service, and async await. Let's kick off things with the endpoint protocol. Think of it as setting up your GPS before you start driving. It defines the address and method for your API request, guiding your app on where to fetch or send data. Next in line is the HTTP method. Once your GPS, or in this case, the endpoint protocol is set, the HTTP client takes over. It acts as your driver, knowing the route and handling the driving to fetch or send your data. Of course, not all journeys are smooth. That's where our request error enum comes in. It's your troubleshooting guidebook, identifying what went wrong during the API request so you can get back on track. Now, let's shift our focus on the service in our networking layer. The service is responsible for making the request. For example, in our Apple Watch Store app, we'll create a product service and a product filter service. These services are the workhorses of our app. They're responsible for fetching all the products and product filter types respectively. They are built on top of our foundational elements, endpoint, HTTP client, and request error, making them modular and easily portable from one project to another. The advantage of this approach is that it allows for a clean, organized, and scalable code base. Each service struct is designed to interact with a specific API endpoint, making your networking layer highly focused and efficient. Now that our foundational elements are in place, it's time to execute our request. But let's elevate our approach by leveraging Swift's async await feature, sidestepping the complexities often associated with using synchronous methods like completion handlers. So for those of you that may not understand what the async await feature means, let me break it down for everyone. In the world of asynchronous operations, imagine you're cooking dinner. While the pasta is boiling, you seize the opportunity to start chopping vegetables for a salad. You're multitasking, making the most of your time. On the flip side, if you were operating synchronously, you'd be boiling the pasta and standing there, waiting for it to finish before you even think about those vegetables. It's like putting your entire kitchen on hold for the sake of the pasta. Now, some of you may think that might be better anyways. But to sum it up, employing async await in your programming is like being a master chef in a busy kitchen. You put the pasta on to boil, and then you move on to chopping vegetables or stirring the sauce. When the pasta is ready, you're alerted with a ding, ensuring both your app and your meal prep operate seamlessly. Now that we have a better idea of how async await works, we are now equipped to build a cleaner and more efficient app. As we wrap up, let's recap what we've covered. We're going to build a solid foundation with the endpoint protocols and HTTP clients. We will also add a request error enum so that we can catch any errors that we may encounter. Once our base is set up, we will create a service that will be used to fetch data. More importantly, now that we have a basic understanding, let's jump into the code and put it all together.